Hi guys. So today our topic is going to be uh, the components of a modern computer. So what do a modern computer have? I mean to say like the motherboard and the CPU box. So since childhood, we have seen many desktops, the systems or the laptops. Like when we go to a computer lab in our college or university, we used to see a few computers, and even we used to own few desktops at our home, right? But we may not be able to see the internal motherboard, like what are the components that lies on the motherboard. But few may have seen it due to their curiosity, but they would have done without knowledge of their parents. Okay, so today I'm going to discuss what are the components that lies on a modern computer's motherboard, and I'll be discussing on how an SRAM exists. So what is an SRAM? And as you know, the people who has already subscribed to my channel, so you would have already known I've been discussing few concepts on cache memories. So the cache memories are the one which are made up of the SRAM, the static random access memory. Okay, and the other type of memory is nothing but the DRAM, the dynamic random access memory. So why do we have two types of memories over here? Why can't we model the same like both the memories with the same? Why can't we model cache memories with the DRAM? Why are we doing with SRAM? And why can't we do model the normal RAM the with the SRAM? Why are we doing with DRAM? So what are the differences? So today I'll be discussing on the basic the cell the data cell of a SRAM, how an SRAM is going to look, and how the data is being retrieved or written into the SRAM. Okay, so first let's start with the components on a modern computer's motherboard. Okay, so when you see a motherboard, we'll have few. Yeah, okay. So now uh, when you see a motherboard, just recollect yourself, like what do you think they would be on a motherboard? So what do you think? Okay, I would say first thing is the processor slot which you will have a processor slot on which your processor is going to sit upon, and once your processor sits on it, we are going to have a few heat sinks like a fan. So whenever you on a CPU, you hear a fan sound, right? That is a heat sink, which is called a heat sink. We have heat sinks and we have a fan to cool, to make it as a cool, like we use it as a coolants. Okay, so we have fan around it, some coolants around that. And what do we have? And we used to connect all the USB or the mouse, the keyboard, the serial ports, everything, right? So we will have some ports over here. Okay, few ports from serial or parallel ports over here. So let's consider all these are for ports, the IO ports. So it can be a, so what are we going to connect in an IO, like for an IO? So we can connect a mouse, we can connect a keyboard, we are going to connect pen drives, the USB ports to the USB ports. So there are few serial and parallel ports, like where we used to connect sorry the projectors, and we have the NIC cards, the network interface cards, to which we are going to connect the LAN ports, the local area network ports. For network we use it, right? And we used to connect audio jack. So all these we used to connect, they act as a IO ports, and through which they are going to communicate with the motherboard. Okay, and what do we have? So you may not be able to grasp few things, but these things you can able to grasp, like the motherboard is going to have a processor, it is going to have few IO ports, and what else? So it is going to have few RAM ports too, few DDR RAM ports, right? So we have a RAM. I don't know whether you have seen it or not. We used to have a DDR memory slots, right? So where you will have a green type of board, and on which we have a few black color chips. So that is called RAM, which is a DDR memory. So we used to put those on these slots, the DDR memory slots. Okay, and what do we have? What else do we have? We have discussed about the CPU socket, the CPU fan and heat sinks, mounting or mounting point, and we have seen the IO ports, we have seen the DDR memory slots, and what do we have? So we have few PCI slots also. Okay, you may not be aware of what is meant by PCI, but if you are aware, that is good, that is well and good. But if you're not aware, we used to have that. So when you come to an industry, you will come to know there is no need to worry about what are PCI slots now. Okay, so we have few PCI slots. And what else do we have? We have a north bridge, we have a north bridge, and we have a south bridge. Okay, so what are these north and south bridge? So why do we have this? So north bridge is the one which is going to, which is being connected with all the primary, the semiconductor parts like the CPU or the memory slots. Okay, so like or some or few types of processors, like any, like a graphic processors or like that. Okay, so these hardware semiconductor components are being connected to your north bridge. And why do we need a south bridge? So we have a south bridge to connect all the IO ports. We use to connect the IO ports, and we connect the hard disk. So hard disk is, it that is also a semiconductor component, but that is a electrical and mechanical part. So when you come to a hard drive, that is an electrical and mechanical part. So that is being connected again to your south bridge only. So we used to connect the hard drives, okay, the disk controllers, or a few other low bandwidth IO devices, or the network interface cards, the keyboard, the mouse, the IO controllers. Okay, all these are being connected to your south bridge. Okay, now how the communication happens? So we have a system on bus, like system on like a bus on board. So we have a onboard bus, which is nothing but the PCI bus that is going to communicate between the north bridge and the south bridge chipsets. Okay, this is how our communication happens. So we have a onboard bus, which is it can be anything. We are like, let us consider a PCI bus. So PCI is nothing but the communication interface that lies between the north bridge and south bridge on your motherboard. Okay, so and what else? So we have few CMOS battery slots. Okay, we have some AGP slots, and we have the IDE connectors, we have some ATX power connectors. So all these are few different components. We have the resistors, capacitors, we have everything. So all the electronic and electrical components, like whatever you see in your day-to-day life, are going to be there, but you may not be able to grasp few components, what are these, but in your career you're going to learn them, like what are they. Okay, so we have seen how what a motherboard contains. So it contains a CPU socket where the CPU is going to be lies on, and we have a CPU fan and heat sinks mounting points, and we have DDR memory slots, we have PCA slots, and we have few IO ports to which your mouse, keyboard, USB ports, serial ports, parallel ports, the local area network, the NIC network interface cards is going to be connected, and the audio jacks. Okay, and we have the south bridge, we have north bridge, and how the south and north are going to be communicating using a onboard bus protocol, which is nothing but the PCI protocol. Okay, so and so what are the components that are being connected to the north bridge? The processing element, or the semiconductor elements like the DDR RAM, or the cache memories, and few other graphic processors. So all these are being connected to your north bridge. And to your south bridge, all the low bandwidth devices like the IO ports, like we have discussed now, the hard drives, okay, the network interface cards, the keyboard, mouse. So all these are being connected to your south bridge. Okay, these are all the major components on your motherboard. Okay, and then now our topic is going to be uh, actually this is a actually this these are my pipelined lecture of DRAM structures. Okay, I'm going to discuss on the memory, the RAM structure, the RAM fundamentals. So along with my SV, UVM, and the cache memories, I'll be discussing the DRAM fundamentals as well. So that is why I've been starting with that. Okay, so let's see what is SRAM. And then today I'll be discussing only about the SRAM level. So what is SRAM, and how the SRAM how the SRAM memory is going to look like, how how the 1 bit storage of the SRAM is going to be stored, how a 1 bit is stored in an SRAM. Okay, and how we are going to able to read or write into the SRAM, and how many transistors does it take. Okay, we are going to discuss all the fundamentals of the SRAM. Okay, so coming to SRAM, uh, SRAM is nothing but the static random access memory. Okay, So what does it contain? So let's see how a binary cell of a SRAM going to looks like. So you're going to have two transistors. Okay. You're going to have two cross coupled NOT gates. Okay. So this is called a bit line. This is a negation of the bit line. Okay. And this is going to be your row select, your row line. Okay. So now uh, how are you going to store? So what is happening over here? So for your data to okay, so these are the columns and this is the row and these are the columns, how an SRAM is going to be modeled. So consider you have few rows and columns of the SRAM. Okay. So consider this is one part, this is one cell, this is one cell, and these are the all individual cells of your SRAM, and each cell is going to contain only one bit of information. Okay. So now whenever a particular row is being selected, okay, whenever a particular row is being selected, since these two transistors are being connected to this row, so both the transistors are in on position now. Okay, both the transistors are in on position. So when they are on, the data which lies on your bit line is going to be transferred through your transistor onto the cross coupled NOT gate network. Okay, and this bit line is going to have, as I told you, the negation of this bit line. If it is going to have 1, it is going to have 0. Okay, when the data transfers over here, so consider this is 1, so your 1 is going to stay over here at this point of time A, and consider this point as B. Okay, so here lies 1. So when this goes through this NOT gate, it is going to be converted to 0, and this point is going to be a 0. Okay, again when it goes over here, again it changes to 1. So this is a cross coupled network. So where you are going to store, or you can say that the data has been stuck over there, or you are going to store it in that way. So how you are going to store a 1 bit information which is in your SRAM is in this way. Okay, so the data is going to be rotating over there itself in the cross coupled network of your two NOT gates. Okay, at one way when you are going to read it from this way, you are going to get 1, when you want 0 you can get it from here. So this is how a 1 bit information is being stored in a single cell of your static random access memory. Okay, this is how we used to write into the SRAM cell. When you come to a read part, in the same way we are going to select the same particular row select and particular bit line. So whenever there is a data in your cross coupled network and that is being read, so as the transistor get on, your data is being read, how they are being written, in the same way they are being read, they are going to be written out. Okay, so this is how a single cell of your SRAM is going to store a 1 bit of information. Okay, and then when you see a large cells of your SRAM, as I have showed you over here, it is going to contain many cells. Okay, many cells. You can so whatever data you want to read out, select that particular row and select that particular column, so that you are going to read out the data that you require. So what do you contain to do that? How the address is being given? Okay, so consider a decoder for the rows, and you will have a mux over here for the columns. Okay, so consider you have some 2 power n rows and 2 power m columns. Okay, so when you are going to give a particular address, which is address plus, you are going to give the both row and column number, right? So you have that. So now whenever you give the address, the row bits, the address is going to be divided into rows and columns. So the row bits have been given to your decoder. This decoder is going to be n to 2 power n outputs. So if you're already aware of how a decoder looks like, it is going to have few inputs and number of outputs, which will be a 2 power of your input. Okay, so now all your data bits, the address bits corresponding to your row, is going to be given by your n to 2 power n decoder, and that particular row is being selected. So when that particular row is being selected, the data which is there in that particular row is being bought, all the data is being bought to a buffer, over here, and from that buffer is going to be connected to a multiplexer, okay, to a multiplexer. So when your column bits, is being given to the select lines of your multiplexer, and that particular column bits is being driven out of your multiplexer. So you are aware, if you are aware of a decoder and a multiplexer, so a multiplexer is going to have a select line. Based on the select line, the data from the input is being given to the output. So for example, you have two select lines and four inputs with one output. When you give 0 0 as select line data, so the 0th line, which is the data, whatever the first line is going to have, is being driven out. Okay, this is how a multiplexer works. Okay, so the row bits are being given to your decoder, where the whole row is being selected, and that is being brought to a buffer over here, and then the column bits are being given to the select lines of your multiplexer, and based on the select line, that particular column bits, the column data is being brought out to by your outside of your multiplexer. Okay, so this is how data is being written or driven out into your SRAM, and how this is how your SRAM cell is going to look like, and a bunch of SRAM is going to be your static RAM, static memory, so which is where cache memories are being made up of. Okay, so this is what I wanted to teach you today, and in our next lecture I'll be teaching about I'll be talking on how a DRAM is going to look like, how a dynamic data RAM is going to look like, and what are the advantages and disadvantages of using both SRAM and DRAM, and why can't we use the dynamic data RAM for your cache, and why can't we use SRAM for your RAM, and why can't we use a same RAM type for both memories. Okay, why are we using only SRAM for your cache memories? Okay, I'll be talking about the advantages and the disadvantages. So as I told, I'll be starting the fundamentals of the DRAM. After once I discuss the advantages and disadvantages, I'll be discussing the few fundamentals of the dynamic data RAM as well, how the dynamic data RAM is going to look like, and how the data is being written out, like how we have seen now in the case of static RAM. So in case of dynamic data RAM, how the data is being written out. Okay, and how the data is being stored, or how the data is being mapped to the cache memories. Okay, so for example, if your cache memory requires some block of data, how your block of data is being given out at the same time by your memory. It won't be at the same time, but in few clocks. Okay, so I'll be discussing that in the next lecture. Okay, so yeah, if you have any doubts, you can please comment in the comment section, and as usual, don't forget to like, share and subscribe to my channel. Okay, and feel free to talk to me whenever you require, as I have mentioned my WhatsApp number on my first lecture itself, the introduction to VLSI, difference between a front end and back end. So I have put my number over there in the description. Okay, you can text me, and whenever I'm free, I'll be replying to you. Okay, thank you so much. Bye.